air conditioning system in newer model vehicles relies heavily on sensor input to allow for correct operation. If an input is compromised in any way, there will be a significant reduction in air conditioning functionality. The evaporator thermistor is one such sensor. A fault in the evaporator sensor may cause error codes within the HVAC module. This thermistor is mounted within the evaporator heater box assembly. The location of this sensor has significant effect on performance and should be located near the evaporator. If incorrectly positioned, this may mean rapid compressor cycles, a reduction in cooling, or even ice up. The sensor is a 2-wire, negative temperature coefficient thermistor. The HVAC module supplies a ground to the sensor, while signal return is monitored via a pull-up circuit. A typical thermistor operating range is usually between 0 to 5 volts. This relates to temperatures from -40 to around 100 degrees Celsius, or -40 to 212 degrees Fahrenheit. As the evaporator temperature influences the sensor, the resistance value and therefore signal voltage will change. The HVAC module may use this input to cycle the compressor, prevent evaporator ice up, and maintain cabin temperature. A fault in the sensor may not always set a DTC. Knowing this, some simple performance checks can be carried out. Start and run the vehicle with the air conditioning on and at its lowest temperature. Place the thermometer in the sensor outlet vent. Connect the scan tool and access the evaporator thermistor data. Compare this with the thermometer. If the readings are identical, we can confirm the sensor is working. If there are any major discrepancies, there may be a fault in the evaporator temperature sensor or its associated circuit. Let's use a scan tool to confirm the fault. With the ignition on, monitor the thermistor data on the scan tool and disconnect the sensor. We should see the value change to around -40 degrees Celsius. With a 3 amp fuse jump wire, bridge the sensor harness connector and monitor the scan tool. We should now see around 100 degrees Celsius. If these values are seen, we have proved that the circuit is functioning correctly. The most likely cause will be the sensor. If the values on the scan tool didn't change, we will need to further diagnose the circuit. Before commencing the following tests, connect a battery maintainer to the vehicle. This will ensure stable voltage readings. Disconnect the thermistor and attach a meter between the battery negative and the signal terminal on the harness side. Turn the ignition on and record the value. You should see 5 volts. Anything over this would be interpreted as a short to voltage. A reading of 0 would indicate a short to ground or open, while anything below 5 volts will indicate excess resistance in the circuit. If a reading higher than 5 volts was recorded, a short to voltage will be the cause. With the meter still connected between the battery negative and the harness signal terminal, turn the ignition off and disconnect the module. Turn the ignition on and watch the meter. If the value is still higher than expected, then the short is in the harness between the two connectors. If the meter reads 0, the short is in the HVAC module or a circuit from the module. To isolate between the two, perform a continuity test between the signal terminal and all other terminals at the module connector. If no fault is discovered, the short to voltage is in the HVAC module and it can be replaced confidently. With the sensor disconnected and the meter connected between the harness signal terminal and ground, a 0 voltage display may indicate a short to ground or open circuit. Move the black probe to the battery positive and watch the display. If any voltage is seen, a short to ground can be confirmed. If the voltage remains at 0, an open is the likely cause. Turn the ignition off, disconnect the module, and turn the ignition back on. If the voltage is still displayed, the short to ground is in the harness between the two connectors. If the voltage drops to 0, then the short to ground is within the module or a circuit from the module. To isolate between the two, perform a continuity test between the signal terminal and all other terminals at the module connector. If no fault is discovered, the short to ground is in the module and can now be confidently replaced. If a short to ground has been ruled out, back probe the signal terminal in the module connector and watch the meter. If 5 volts is seen, the open is in the harness between the two connectors. If the correct voltage still isn't displayed, turn the ignition off and disconnect the module connector. Check the module connector for terminal corrosion and pin retention. If this is okay, the open is within the module and can now be confidently replaced. With the meter connected between the signal terminal in the harness connector and battery negative, 5 volts should be seen. If a reading lower than 5 volts, but greater than 0 is recorded, there may be excess resistance in the circuit. Move the meter lead to the module connector and back probe the signal terminal. A display of 5 volts here will prove there is excess resistance between the two connectors. If the display is still lower than 5 volts, disconnect the module connector and check for bent, damaged, poor terminal retention, or corrosion. If no fault can be found, the excess resistance is internal to the module. With the meter connected between the sensor low reference terminal and battery positive, battery voltage should be seen. 0 volts will indicate an open, while excess resistance or a shorter voltage will be seen with any reading above this. Move the meter lead from the battery positive to battery negative. If any voltage is displayed now, a shorter voltage in the circuit can be confirmed. Turn the ignition off and disconnect the HVAC module. Turn the ignition on while watching the meter. Any voltage displayed would prove a shorter voltage between the two connectors. If the meter values stayed at 0, then the shorter voltage is in the module or a circuit from the module. Perform a continuity test between the low reference terminal and all other terminals at the module connector. This will rule out a circuit short. If no continuity is seen, then the shorter voltage is in the module. With the meter connected between the sensor low reference terminal and battery positive, turn the ignition on. Battery voltage should be seen. With a shorter voltage ruled out, 0 or substantially lower than battery voltage will indicate an open or excess resistance in the circuit. Move the meter lead to the module connector and back probe the low reference terminal. If battery voltage is now seen, the open or excess resistance is in the harness between the two connectors. If battery voltage is not seen while back probing the low reference terminal, turn the ignition off and disconnect the module connector. Check for terminal retention and corrosion. If no fault is found, the open or excess resistance is within the control module. If we have proved the signal and low reference circuits are okay, then the fault can only be the sensor. Well, there you have it. A nice and easy way to test and diagnose the thermistor circuit on a typical HVAC system. With continuous training, we can make the job of fault finding easier and more enjoyable. Thanks for watching. See you soon.